Let's do this. Geometry. Study guide. Perfect timing. Into the song. Alright, so guys, I'm not going to really stop and answer questions. I want to get through it. Okay? And it's recording, so I'll post this and you can go back and re-watch it if you missed something. Alright? If it's a quick clarification as to like what I did, that's fine, but I'm not going to like break down the problem multiple times. I'm going to make sure we get through the whole thing so everybody gets a chance for me to go over everything that's going to be on the test. And those over there. So let's get to it, huh? Let's see here. Purple, blue, green. This should be good. Maybe a black and a maroon. Alright, let's start with green. Alright, what's the property here? Anybody know it? This one?
Yeah.
Yep. Symmetric. It's a symmetric property, right? You can put x on the left or x on the right. Now, remember when you do a proof, and you want to change if the x is on the right side, and you want to put it over on the left, and change the way everything's set up, that's fine, but you have to list that as a property. You have to say symmetric property in order to flip it. In order to write, like if I wrote line 1, I had 7 equals x, and then line 2, I put x equals 7. Over here, I'd have to put symmetric, okay, as my reason. Does that make sense? Okay. X plus 7 equals 7 plus x. What's that? Josh? Commutative. Commutative property. Okay? Meaning you can switch x plus 7 or 7 plus x. Addition can go either direction. Does that work with subtraction? No, right? Because if you do have a subtraction, you get a negative answer or you get an opposite answer. Okay? Alright, so we want to prove here for number 2 this. So, sorry, this is our statement. Reasons. My statement should be 126 equals 7 times x minus 5. I'm just rewriting what they give me. And I know my last step, we'll just call it step blank, x equals 23. That should be my answer if I do everything right. And my reason for number 1 is just that it's given. Now, what I'm going to tell you how to do this. Anybody remember? Okay, you solve everything over here when you get one like this. You solve it all out, then you go back and tell me all the reasons. So the first thing I know I need to do is distribute. So I go 126 equals 7x minus 35. And that was because I used distribution property. Okay. Then I know I have to bring that 35 to the other side by adding it to both sides. What is 126 plus 35? 161. Right? 161 equals 7x. That would be my addition property of equality. Right? Remember I said you can write POE, and I get that. It's crooked, isn't it? Oh. There you go. Sorry about that. Now, what do I do? Anybody want to give me a suggestion? Divide by, exactly. Did I use purple on that one? I'll use red. Divide by 7. Now, even though I'm dividing, who remembers we don't call it that? Yeah, it's actually multiplication because we're actually multiplying by 1 over 7. What's 161 divided by 7? Is it going evenly? 23 times? We'll check that out. Okay, so 4 would be multiplication property of equality. Now there's one more step I have to do to get x equals 23, but I am on my last step. And what did I just talk about? Aha, yeah. I have one more reason. reason how I can go from here to here, symmetric property. It's actually a property of equality, I think, but it's not, it's different. Alright, y'all follow that? So just go through, solve it, and then go back and write down all the steps that you did. Simple enough, right? Okay, gotta be able to solve those by now. It's algebra on the left. The geometry part is on the right, telling you to just label your steps. Okay, so let's prove that AC equals 47. So now it doesn't give us the equation. We have to set up the equation ourselves. So there's a couple more steps here. We have our statement and our reason. So what does it tell me? I have ABC, so it's a line where B is in between A and C. That's what that means. A dash B dash C. Just saying there's some line and B is in between them. AB equals 9, BC equals 3x minus 4, and the whole thing equals 5x minus 23. So I know what my equation is going to look like. It's going to look like this plus this equals this. So you would do 1, and you would write down all of that. You would write this, this, and this, even this if you wanted. Okay, you write all that right there, and that's your given. Okay. Don't do that on the test. I'm only. Oops, sorry, it's really low. Don't do that on the test. Actually, write in what you need. I'm just telling you because I don't want to write it right now. But you would write all that here. So that's given. Then I can say the reason, the thing you know what to do is you know that this plus this equals the whole thing. So I know that 9 plus 3x minus 4 equals 5x minus 23. And I know that that's true because why? How do I know that's true? Anybody know? Because two pieces make a whole, right? What's the technical term for that? Definition of between. Okay, B is in between A and C, therefore AB and BC must add up to the whole thing. So definition of what it means to be in between something. Right, if I took the distance from me to Gabby and added it to the distance from me to Sagoon, it would be the same as the distance from Sagoon to Gabby, because we create a straight line. Alright, now I just go and I do exactly what I did up here, okay, where I solve out all my steps. So I'll go ahead and do that. I'm going to go through all these steps and then I'll go back and add my reasons. So I simplify right here. 9 minus 4 is going to be 5 plus 3x equals 5x minus 23. I'm just simplifying, combining like terms. Then I take my, I'll just do both 2 and 1. I'll take my 5, bring it over here. No, hold on. Let's bring 23 over here and 3 over here. That's going to give me 28 on the left equals 2x. Okay, so I just basically subtracted 3x on both sides, and I added 23 to both sides, and that's what I got. Then I'm going to divide by 2, so I would say that x equals 14. We're not done yet, because I know x equals 14. I have to substitute that in to my original 5x minus 23, because it's saying what is AC. That's what we're trying to look for, right? So AC, I would say 5 times 14 minus 23, substitution, and I solve that out. What is that? 50, 60, 70 minus 23, 47. Alright, cool. On point. I would write this as AC equals that. I would put it on the other side when I write it, so that I don't have to do an extra step and do symmetric property. So I should write it as AC equals this instead of this equals AC, okay? So then my answer would be AC equals 47. Okay, cool. So I worked it out. I solved it. Can you all follow along with that? We're just solving equations. You learn this, we've learned this, we've done this. Kind of keep doing it forever until you graduate math and you don't have to do math anymore. Now I just have to go back and label what I did. So I go, okay, I simplified. Then I added some addition, property of equality. Then I divided or multiplied, right? So multiply multiplication property of equality, multiplication property of equality. Then I substituted, that was a cool step. And then I simplified again. That was my last step. So I just simplified this. I multiplied it out, simplified again. Okay. When I break it down and do it, wait, you have a question? It's asking you to prove it. So you have to prove it. Which means you could write this in paragraph form. I didn't teach you guys to do that. It's just typically harder. This is a lot more easy to grade for me, and it's easier for you to see like each little thing, as opposed to in a sentence having to write it all out. But yeah, this is what you need to do. When you see proof, guys, when you see proof, that means 2-column proof. Right? Does this make sense though? Does this help to do the whole thing and then go back and add your steps? Is that helpful for you guys? Okay, yeah. Because sometimes we're like, oh, I don't know what the next thing to call it. We'll just do it, and then you can just try to remember whatever you did is called, okay? Alright. Next page should go by a little faster. No proofs. Alright, so complete the following statements. There's congruent or supplementary. This should be pretty easy. You have a 50-50 chance. Alright, vertical angles. What are they? Yeah, they're these angles. This one, or like this one and this one. Right, no matter what we do with these pens, these two angles right here are always going to be the same size, so they are congruent. Okay? Alternate exterior angles. Just draw a quick little. Alternate exterior angles would be this guy and this guy if they're parallel. Right? I'll make sure I write that on the test for you guys to assume that they're parallel, because they're not always congruent. But yes, they would be congruent. Good answer. What about consecutive angles? That's these guys. Supplementary. There we go. Alright, alternate exterior angles. Did I put that in there twice? Oh no, this is alternate interior angles. But it's still congruent. So alternate interior angles would be like this one and this one. Okay, these purple ones. That would be number 5. And yes, those are congruent. And so are these. These are also congruent. Okay. And then corresponding angles. Corresponding angles means like if it's the top left or top right, then this is also the top right. And they are congruent. Okay. So pretty much all of them are congruent except consecutive angles, right? Easy to remember? Okay. Hopefully those are easy points for you guys on the test. Let's go down here. Alright, some more basic definitions. What is a linear pair? Right, it's two angles that are joined. They have a common line or ray that they share. What does that mean? What is a linear pair? Congruent, add to 180 or add to 90? Okay, so sometimes they can be congruent. Actually, there's only one situation where they could be congruent. When you have something that looks like this, and this angle right here is 90 degrees, which means this is 90 degrees and this is 90. But every other situation, they're different. But the whole thing adds up to what? 180. So linear pair is add to 180. Alright. Vertical angles, like we talked about before, yeah, they're congruent. So basically, double your value for that one if you get it right in one area. Alright, so what that's saying is, maybe I should make you guys draw pictures for the test. Label it and draw a picture showing the example. Right, the symbols are, yeah, that's okay. Complementary angles means what? What do you mean to be complementary? Adds to 1, adds to 90. Yep. So up here, a linear pair, actually here, let's go down here, supplementary angles means adds to 180. But the difference between supplementary and a linear pair is that these angles don't have to be touching. Well, you can have two completely separate angles, one over here, one over here. Alright, they don't have to be connected at all. So those can be, that's a supplementary angle. But they're essentially the same thing, a linear pair and supplementary angles, except the linear pair is connected, supplementary angles are not. Okay. Alright, easy page. Can that give you guys a good chunk of points on the test? Alright. This one's not a proof, and it really doesn't require a lot of work. Okay? Let's just solve the equation. You know, this one, because it doesn't say prove, I don't have to list out all my reasons. So it says find the measure of each angle if MO bisects LMN. So if MO, if this line right here is bisecting this whole thing, that means it's cutting in half, which means these are equal halves. So I can say that 3x plus 5 equals 3 times 2x minus 10. Okay, take that, distribute that out, 3x plus 5 equals 6x minus 30. Okay, remember to do this. You guys did a lot of you guys did this as a mistake when you were solving it. You did 3 times 2, and then you forgot to do 3 times negative 10, and you will get the wrong answer. Okay, don't do that. Now we're going to take 3 and bring it over here. Gives me 5 equals 3x minus 30. Then I take 30 and add it to both sides. So I get 35 equals 3x. Divide both sides by 3. X equals 35 over 3. Yes, you may get a fraction now and again, and that's okay. But that's not my answer. It wants me to know what is angle 1 and angle 2. So all I got to do is take this, plug it back into either one. And since I know they're equal, I don't need to plug it into both, unless you want to do that to make sure you got the right answer, to check your work. So I'm just going to take that, plug it in, so I have 3x plus 5 is the thing I'm going to use, which is 3 times 35 over 3 plus 5. If you ever know anything about multiplying fractions, you can always cancel like that. So I get 35 plus 5, which equals 40 degrees, and that would be my answer for both angle 1 and angle 2, because I know they're the same. Okay, so solve it out, plug it back in, there's your answer, okay? Alright, we got a proof again. I need to put this down here. Alright, a little more abstract. I think it's the last proof. Alright, GH equals JK, so we know that I know that this is equal to this. What can I say HJ is equal to? Huh? I could say that this is equal to itself, can I? HJ equals HJ. Something to think about. It's helpful for solving these kind of things. Okay. Alright, so it wants me to prove that this right here, this long piece, is congruent to this other long piece. So I would write number 1, given, which is GH equals JK, and that is my given. Now, like I said, HJ tells me something, and this is where it gets a little more outside the box thinking. HJ equals HJ. What's that called? What property is that? Reflexive. Alright. I don't necessarily know if you have to put that in there, but it's helpful to be able to identify that. Alright. I know that GH plus HJ has to equal the whole thing. Right? GH plus HJ equals the whole thing, GJ. How do I know that? We talked about that on the last problem on the first page. If you have 3 points on a line, and you take 2 of the pieces and add them together, they equal the whole thing, what's the reason for that? Okay, memorize this. We talked about it before. Definition of between. Okay, the definition of in between. Now, you can actually do 2 steps here. You don't have to write it twice. You can also write the HJ and JK equal to HK. Okay, so HJ plus JK equals HK. Alright. Now we gotta somehow get these equal to each other. Well, up here GH and JK are equal to each other, so I can actually substitute those with each other, can't I? Right? And HJ is already equal to itself. So what I'm going to use is our little sneaky and our best friend in math. One of our best friends, this guy, I don't know what we would do without him. We're going to substitute. So I'm going to take GH and I'm going to substitute it right there. Okay? So I'm going to say HJ plus GH equals HK. And I use substitution. Okay, I substituted. Now wait a second. This is the same as this, isn't it? Now it's backwards, so I have to, because I wrote it backwards and it just worked out that way, I have to write this. I have to write GH plus HJ equals HK. I have to change this around. Can somebody answer the door? I don't know the door's open. Come in! Alright, HJ plus GH. I have to flip it around. Is that whole plate is for me?
Yeah.
Oh, thank you. You can all come back never. No, that's mean. Why would I tell them that? I know. You guys are going to have to help me eat it then. I know, or spread it out throughout the whole day. No. I can eat some sweets, man. That's deadly. Oh gosh. Alright. Alright, HJ plus GH equals HK. I have to flip it around. What do we do when we flip it around? What's that called? It's on the very first symmetric. Are you sure? We're only switching around the left. We're not flipping the whole thing. Commutative. We did that on the first page, right? So that's my commutative property. I'm missing an N in there. You get what I'm saying, though. If you happen to write it the other way around in the first place, you wouldn't need to write that step. So it's up to you. Okay? Alright, now I have this equals this, and I have this equals this. I just have to do one more excuse me. I have to do one more substitution. Okay? Look, I have GH, HJ equals HK, and GH, HJ equals GJ. So I'm going to take this, substitute it in right there. So I'm going to say GJ equals HK. Substitution our friend. Now the only thing that makes this look different than this is that this is in congruency. So I need to just write that as definition. So I write basically what they're asking me to prove. Definition of. That's the definition of congruent. Okay. Now when you look at the whole thing, and you're just staring at it right now, it's like, oh gosh, so many letters. What's up with this? When you break it down piece by piece and you understand it, it's not hard, guys. Okay, so go back, watch the video over and over again. If you didn't get it, because we got to move along. Alright. Oh, another proof, really? I thought that was the last one. Is this the last one? Yeah. Okay. Let's do this one quickly. I don't think it's very long. Alright. It says that these two, P and Q, are parallel, and there's a transversal. So my statement is P is parallel to Q. That's my given. And, well, P is parallel to Q, and I'm trying to find 1 and 4. So I can say, well, I know that you could pick any one of those ones on that page that we did over here with all these things, right? Just pick any one of those properties. Okay, I like corresponding angles, so I'm going to say that angle 1 is congruent to angle 3. Why? Because they're corresponding. Angle 1 and 3 are congruent because they're both top left. They're both right here in the same spot on the different intersections, okay? Then I'm going to say, okay, well, what else do I know about? I know that angle 3 plus angle 4 equals 180. Why? Go back to that same page. What reason is that? They're a linear pair. They both share a common ray. They're a common part of that line that goes through that intersection. Alright, well, but I just said that angle 1 and angle 3 are equal. Aha. So I can say that I can do some substitution here. And I can say that angle 1 plus angle 4 equals 180 using substitution. I'm telling you that substitution is your friend. Don't forget it at home. Alright, well now I'm pretty much where I need to be. Angle 1 and angle 4 are supplementary. So I'm actually, that's literally where I'm at. I'd say angle 1 and angle 4 are supplementary. That's what it wants me to prove. And I know that because that's the definition of supplementary, that angle 1 and angle 4 equals 180. So the definition of supplementary. That is literally the definition right there. So that's how I can conclude that angle 1 and angle 4 are supplementary, because that's the definition of supplementary. Right, down here it's asking which lines can be proved to be parallel from each given statement. Now I didn't have we'll just write these A, B, X, and Y. Okay? On the test I think I also forgot to print that, so when we take it I'll make sure you guys go label those something so that everybody has the same lines. Okay, so this is line A, line B, X, and Y. So it's saying with angle 1 and angle 16, so if I take this angle and this angle, which two lines can I prove parallel? Well, none. Okay, it would require me to do 2 steps in order to get the lines to be parallel. I'd have to first say that 1 and 8 are congruent, and then I would have to say that 8 and 16 are congruent so 1 and 8 could be alternate exterior angles, and then 8 and 16 would be corresponding angles, but that's 2 steps. So whenever an angle is 2 steps away, and you can't directly say one of our 4 or 5 different relationships, then I know that I can't get any angles proven parallel. Now we're looking at angle 2 and angle 4. Oh, sweet. Those are both on the bottom right side of those intersections, and they have a common transversal. So that means I can say these two lines are parallel, so I could say that A is parallel to B because those are the two lines they both share in common. Or those are the two lines that transversal cuts across. Okay. If I say that angle 9, which is over here, is supplementary to angle 12, okay, then what two lines do I know are parallel? Well, I know that 9, if they're parallel, then 9 and 11 would be congruent. And if 9 and 11 are congruent, then that means that it would be supplementary to 12. So I could say that A is parallel to B. No, sorry. Yes, A is parallel to B. Because those are the two lines that this transversal that I'm looking at cuts through. Okay. Alright, moving right along. We're about 15 minutes. I think we can do this. It's getting easier. It's getting down to the stuff that you like. Alright, find the distance, midpoint, and slope of all three of these points. Alright. So that's kind of repetitive. So if you can do one, you can do them all, right? You want me to take some of them off the test, or you want me to leave them on there because you know how to do these ones? Yeah, that's what I thought. Okay. I'm going to leave them on. They're a little different. This one has 1 negative, this one has 2. Alright, let's do our distance first. What is our distance formula? You gotta know it, okay? D equals, here, let's just write it up here. Square root x2 minus x1 plus, squared, y2 minus y1 squared. Alright, so we're going to plug points in for that. So I got my x2 and x1, so 1 minus 9 plus 4 minus 0. Okay, now a lot of you guys will do like 0 minus 9 and 4 minus 1. Don't do that. No, you match your x's up and your y's. Okay? Doesn't matter which one goes first as long as the same one goes first in both. So if this is going to be x1, y1, then this has to be x2, y2. But if you want to make this x2, y2, then this has to be x1, y1. I usually just do whatever one in order, okay? So I don't get confused. So that's going to be negative 8 squared, which is 64, plus 4 squared, which is 16. Add those together, 70, 80, right? Square root of 80. Now I got to break that down. Breaks down into 20 times 4. 4 breaks down to 2 and 2. 10 and 2. 2 and 5. Because it looks like I got a pair of 2's right here. Pair of 2's right here. And this little lonely 5 left over. So that would look like 1, 2. Pull out another 2. 5 left over. 2 times 2 is 4. So that's 4 square root of 5. I know. You're like, no, prime factorization. I don't like that. And then I get confused because, wait a second, there's 4 2's, we only took out 2. Remember, when we're talking about square roots, right, it's the opposite of squaring something, which means in order to get something out, we have to find 2 of the same number that are being multiplied together to get that. So that's why 2 times 2 equals 4. But the square root of 4 is 2 times 2. Or, sorry, the square root of 4 is just 2. The square root of 4 is not 2 times 2, right? The square root of 4 is just 2. That's why we only pull out 1, 2. Anyway, just remember, the couples get married off and they come outside. 2 become 1. So I have 2 2's becomes 1 2. 2 2 becomes 1 2. And single people stay inside by themselves. Okay? That's what you remember about that. Alright. Midpoint. What's my midpoint formula? x2, well, it's x2 plus x1 plus x2 over 2, y1 plus y2 over 2. So it's like 9 plus 1 over 2, which is 9 plus 1 over 2, which gives me 10 over 2, which gives me 5. And then 0 plus 4, over 2, which gives me 4 over 2, which gives me 2. Boom. There's my point, 5, 2. That's the midpoint between these 2 points. What do you mean? Yeah, from the distance, midpoint, and slope of the following. Yeah. And then the slope is, remember slope, y2 minus y1 over x2 minus x1. So very similar kind of equations here, don't we have? Yeah. That would be, let me do another color so it's a little different for you. Midpoint would be y2 is 4, y1 is 0, so it's 4 minus 0 over 1 minus 9, m equals 4 over negative 8, or negative 1/2 would be my answer, okay? Now, you should be able to start knocking these out of the park really easily, okay? Have a calculator with you. Don't bring a calculator, make your life harder, okay? Again, you shouldn't need a calculator, but just to verify, make sure you're not stressing out too much about all the calculating. It's got to become second nature, guys, okay? All right, you'll do the same thing for this, and do the same thing for this, okay? There's nothing different, so I'm not going to go through that right now and drown and bore you. But just make sure you get your numbers in the right place. You mess up the numbers, you mess everything up, okay? Last page. Last page. Not as hard as you think, okay? Now, when we have a general form line, when it's written in general form, the easiest way to graph it is, well, there's 2 ways, okay? It wants me to get the answer in slope-intercept form, so I might as well just switch it to slope-intercept form and then graph it, as opposed to graphing it and then switching it into slope-intercept form. I'm going to have to do it anyway. So let's do that. We're going to do 2x plus 3y is negative 12. And slope-intercept form just means what does y equal? Y equals what? Okay, so I take 2x, bring it to the other side. That's going to leave me with 3y equals, now normally you just tag this on at the end and you do negative 12 minus 2x, but we have a particular form we want, so we want x to be in the front, so we'll do negative 2x minus 12, okay? And then I just divide everything by what? 3, okay? I have to divide each one. Don't just do this side and this side, you'll mess it up. This whole thing, every single term, so 3 cancels out, I leave with y. 2 divided by 3 is negative 2/3 x, okay? 2/3 doesn't, just leave it as a fraction. And then negative 12 divided by 3, negative 4. So here's my slope-intercept form. I could write that in right here as my answer. Okay. Now I just have to graph it, okay? Simple enough. I take my y-intercept, which is always this term right here. That's where I start on my y. So I go 1, 2, 3, 4. Okay, make sure you get the right starting point. A lot of you guys keep messing up your starting point. Get the right starting point. All right, now negative 2/3 means I start by going down, but remember, we always go to the right with a run. We never run to the left. We always run to the right. So just like a Mario, right? You can never run back. Once you run forward, you can't. The screen doesn't go backwards. You have to run to the right. So yeah, the old stuff, not the new stuff. Yeah. So we're gonna go down 2 because it's negative, and then we go over 3 to the right. 1, 2, 3. So this will be my second point, and that's all we need. That's all we need to make a line. Is those 2 points. So there's my graph. Okay. That easy. Practice. Get like a whole list of lines in this graph. So it's easy for you to graph them, okay? Write the slope-intercept form of the other 2 equations that are parallel and perpendicular to the line y equals 1/2 x plus 2 and the point 4, negative 5. Okay, so this is what a lot of people do, and I'm going to tell you this is I don't want to say a trick, but you do not need this too. It is irrelevant. Okay? Huh? Oh, sorry. You do not need that 2 right there. Okay? That is a line, and you know what? I'll show you what that line looks like. Just I'll draw it on this graph with this color, okay? You start here at 2, and you go up 1 over 2, and you draw a line, okay? So it's asking me, what's a line so this is point 4, negative 5. Okay, let's graph that. 1, 2, 3, 4, negative 5. 1, 2, 4, 5, okay? So what it's saying is there's a line that goes through that point that's parallel. You just eyeball it. There's this line over here, okay? And it's parallel to this line. These lines are parallel. I know I didn't draw it perfect, but what is the equation of this line? It gives me the equation of this line right here, y equals 1/2 x plus 2. It's saying what is the line that's parallel to that line, but it goes through this point. Okay? So the only thing I need, the only piece of information I need from this line is the slope, because parallel lines have the same slope. Okay? So I know that this other mystery line is equal to y equals 1/2 x plus b. Okay? But that's not an equation of a line. An equation of a line has the b. So I have to solve for b. But I have 2 pieces of information. I have x and y right here. So if I plug these 2 into here, I can solve for b and get my answer. That would give me negative 5 equals 1/2 times 4 plus b. When you solve that, what's 1/2 of 4 is 2. Subtract that from both sides. So I know that b equals negative 7. So that's not my answer though, because it was my equation. So now I take b and I just plug it right back in there, and that's my answer. Y equals 1/2 x and then minus 7. Okay? If you have your slope and your y-intercept, that's all you need for an equation of a line. Y and x can be a lot of different things. Okay, in fact, a line, you can put anything in for y and you'll have some x that goes with it. So that's why we don't write the 4 and the negative 5. If we wrote the 4 and the negative 5, then we would just have a point. We wouldn't have an equation of a line. So, does that look about right? Let's see. 1, 2, 3, 4, 5, 6, 7. You know, if I drew it better, it probably would have been right here, wouldn't it? Up 1 over 2, up 1 over 2, yeah. That looks about right. Okay, now for the second one, it's just saying, okay, do the same thing, but what about this perpendicular line? What about if I had this point and it was perpendicular? It was an exact opposite, right? And you created a 90-degree angle. Well, the only thing I need to know is what would be the perpendicular slope. Do you guys remember how to get it? If the slope of this line is 1/2, what's the slope of a perpendicular line? Okay, so you take the original slope, you flip it over, and then you also make it negative. Okay? Or if it's negative, you make it positive. You flip the sign and you flip the fraction. So it's positive 1/2, so it's going to become negative, and then it's 1/2, so it's going to flip to 2 over 1. And 2 over 1 just equals 2, right? So just write negative 2. So I know, the same thing I had up here, I could write y equals negative 2x plus b, and do the same thing. Plug in these points and find b. So that gives me negative 5 equals negative 2 times 4 plus b. b equals 2 times negative 4 is negative 8. Add that to both sides. 3, right? Okay. Now I take b, plug it in here, and that'll be my final answer, okay? Y equals negative 2x plus 3. Does that look about right? Let's see, plus 3. Yeah, you know, if I would have drawn it better, if I would have drawn it here, it's about, yeah, it looks like about right. I'm in the right ballpark at least, you can't know for sure just by graphing it freehand without having points, okay? Alright, simple. I know. Well, okay, so Algebra 2 has the same exact kind of question on their test, and they're still struggling with it even though they learned it last year. So, don't think that you're going to, this is important. You'll see this again. But just remember conceptually, understand it, okay? Now this last one, really quickly, you will have to know all of the different types of triangles, okay? Here's a few to practice, but don't think that if I know these three on here, that I know all the possible things that could be on a test, okay? What kind of triangle is this right here? So right, but what else? Scaling. Because none of the sides are equal, because it doesn't have any lines, so I know they're not equal. Oh, sorry. Right scaling, okay? What about this? There's an obtuse right there, so it's an obtuse scaling. This one has two sides that are congruent, so that makes it a what? Acute isosceles. I think I spelled that right. It's okay, get it close enough on the test and I'll give it to you. Oh yeah, acute because they're all less than 90-degree angles, right? What are my other possibilities? I have an equilateral triangle, equiangular triangle, right? Okay, so just know that. All right, guys, we got through it. We did it. Let's just pray that the computer actually recorded my voice, or at least recorded the video, because you can see all the steps. You don't necessarily need to hear my voice. You can only pray, right? It says it's recorded.